Hi guys, welcome again to Simplified RSA, the guys who makes it looks easy. I'm Mr. Mayemane, and today we are looking at this question. I'm not sure if it's gonna fit here, but this one. So on my side, obviously I see it from here. So it's question 7.1, we have to determine f prime x from the first principles if it is given that f of x is that. So first principle, that's the keyword. We don't just differentiate because f prime x, that's what differentiation is. And then 7.2, we have to determine the y over dx if given that function there, or just an equation, which is y is equals to 4x to the exponent 8 plus square root of x cubed. And then we're going to do 7.3. We are given that expression, which is y is equals to ax squared plus a, and then we have to determine dy over dx for 7.3.1, and 7.3.2, we have to determine dy over dA, right? Without wasting time, today we're not doing the basic differentiation rules because now at this point we do understand what differentiation is about. But I don't think I have spoken about the first principle before. Let me show you how to solve 7.1. Let's start with the first one right now. Do our thing, solve 7.1, go in that order, and then we'll be done in no time. So here we are given f of x is equals to 4 minus 7x, right? And we know that to get the differential using the first principle, we say that f prime x is equals to the limit of x approaches 0 of f of x plus h, because this is a slope or a gradient, is minus f of x is the slope or a gradient between 2 points. So this is how we represent f prime x by the first principle. So this is the first principle of differentiating. As you can see, the first principle consists of f of x plus h subtracting f of x. F of x is exactly this f of x that you see here. This f of x is exactly that. You substitute that. So meaning you're going to substitute this expression where there's f of x. But what about f of x plus h? Somehow you have to calculate that somewhere separately if you can't do it exactly directly from here. So getting f of x plus h is going to be 4 minus 7 into x plus h. So the secret is, let me just put that like that. Yeah. So the secret is where there's x, where there's f of x, if f of x is equals to that, to get f of x plus h, where there's x, you just substitute x plus h. So you see f minus 7, where there's x, we substituted x plus h. And then to simplify this, we'll get that f of x plus h is 4 minus 7x minus 7h. So f of x plus h is equals to 4 minus 7x minus 7h. So where there's f of x plus h on this formula, I will substitute by that. Now, we can continue. Oh, by the way, we are solving 7.1. We are solving 7.1. So continuously, we're going to say then, I meant to say continuing. All this over h. Then I will substitute f of x plus h with what it's supposed to be, which is 4 minus 7x minus 7h. So 4 minus 7x minus 7h there. But then I have my f of x, which is f of x is 4 minus 7. So it's going to be minus 4 minus 7x. I'm putting the minus outside because I want to show you that I'm substituting f of x with that, but the sign might affect what is inside. And the whole point of using color is just to understand the whole distribution. So now let's simplify this further. Then we'll have 4 minus 7x minus 7h minus 4 times that is going to be minus 4 minus times minus 7x going to be plus 7x. All of this all over h. Now, if you see here, 4 minus 4, I'm grouping the terms, the like terms with the like terms, whichever one I have. So 4 minus 4, this and this will cancel. It will give me 0. Also, minus 7x plus 7x. This and this will cancel. It will give me 0. And then I'm only left with minus 7h over h. Therefore, f of x is equals to the limit of x approaches 0 of minus 7h over h. Minus 7h over h. From here, obviously, we can see that the h will cancel. So we only have minus 7, which is our limit. Therefore, f prime x is equals to minus 7. Because the limit now, we've eliminated everything for us to be left with that. So f of f prime x of that is minus 7. But without using the first principle, we all know that from having f of x is equals to 4 minus 7x, we could have went straight and say f prime x is equals to the differential of a constant number, which is just 4, is going to be 0 minus 7x is just going to be minus 7. Therefore, this was just going to be minus 7. We all know we could have done this, but then because of the way first principle was mentioned, for us to use the first principle, we had to make sure we use this to differentiate. So this is the first principle of differentiation. That's what we have for 7.1. Moving along. So 7.2, we are requested to determine the y over dx if y is equals to 4x to the exponent 8 plus square root of x cubed, right? This time around, we don't necessarily have to use the first principle. If you want, you can use the first principle, but it's going to take you way too long. The first principle, the reason why 7.2 was 4 marks for something that could have been even half a mark if it was to be applied using the rules. That's because the first principle is just a longer way, or it's just the explanation of the fundamental of calculus, which is another story. But now, to determine the y over dx for 7.2, this is how we do it. We are given that y is equals to that. You don't just go straight and say dy over dx from this one. You have to simplify it further, because we know that if you have y is equals to ax to the exponent n, for instance, we know that the differential of this, we know that the y over dx of this is the same as n ax n minus 1. This is the rule that we have to know. So this one looks a bit like this. But what about that? It means we can't just go straight and differentiate. We have to simplify further. So to do this, this is how we go. To simplify this one further, I will then have y is equals to 4x to the exponent 8 plus x cubed to the exponent 1 over 2, because square root is the same as half. We know it's exponential rule that says if you have x to the exponent, if you have square root of x, the same as x to the exponent of half. It's just the rules that we are following right now. And then to simplify this further, we'll have y is equals to 4x to the exponent 8 plus x to the exponent 3 over 2, because I multiplied the exponents using exponential rules again. We all know the exponential rules. Otherwise, if you don't know the exponential rules, just scroll to the video where we are explaining the exponential rules. But then from here, now this is the form where we can differentiate. We can find our dy over dx using these two. So now dy over dx of this, you know the rule. This multiply by that, subtract 1 from n. So it's going to be 8 times 4x to the exponent 8 minus 1 plus this one comes in front, 3 over 2 times x let me use my times like that. Let me just put my times not to seem like the x that we are solving. So it's a multiplication, this one. 3 over 2 multiplied by 3 over 2 minus 1. Here we'll have 8 times 4 is 32, x to the exponent 7, plus 3 over 2x, 3 over 2x, because 3 over 2 times x, 3 over 2x. 3 over 2 minus 1, we solve it like this. So we have 3 over 2 minus 1. This is a fraction. Any number is over 1, right? The lowest common denominator here is 2. 2 goes once here. 1 times that is 3. Minus 1 goes how many times here? It goes twice. 2 times that is 2. 2. Therefore, we'll have 3 minus 2 is going to be 1 over 2. So 3 over 2 minus 1 is 1 over 2. So let me just put this like that so it can make sense. We could have said this is our answer, right? We could have said this is our answer. But then if you want to brag and simplify this further, just like I said, that the square root of x is the same as x to the exponent 1 over 2, why don't you just put this as a square root, right? Just to put your answer in the most nicest form for whoever who's marking to can know that, yeah, man, this person knows their story. Then you'll have x to the exponent 7 plus 3 over 2 square root of x. So I can say this is my final answer. So this is the dy over dx for that. That's how you solve 7.2. Guys, this next one is just 3 marks. I mean, 7.3.1 is 1 mark. 7.3.2 is 2 marks. It's just 3 marks, meaning you don't have to think hard. It's just basic application of differentiation as you know it. Wait. So yeah, 7.3 shouldn't be that hectic. And the mosquito is late, which is sad. Anyway, let's go to 7.3.1. So on 7.3, we are given that y is equals to a x squared plus a. Y is equals to a x squared plus a. 7.3.1, we have to find dy over dx, meaning we have to differentiate y in terms of x. We have to differentiate y in terms of x. We only consider x as a variable, and then we consider the a's as probably coefficient there or just a number there. So we're only differentiating dy over dx, y in terms of x. Therefore, this is going to be x squared 2 constant. It's going to be 2 times a x 2 minus 1 plus, if this was a number, whether it's 10, whether it's 100, whether it's a million, whether it's whatever number it can be, we know that if f of x is a number, I can choose a specific number that I want. I can say 9. Therefore, f prime x is 0. The differential of a constant number with no variable on it is always 0. Therefore, it's going to be 0. This means our dy over dx for 7.3.1 is going to be 2a, 2 times a, 2a x, 2 minus 1 is just going to be 1. And if since it's to the exponent 1, I don't necessarily have to show the 1. So 7.3.1 dy over dx is 2ax. 1 mark. Nothing much to be done there. Therefore, 7.3.2, just because of the coloring there, let me use a different color. 7.3.2, we have to find dy over dA. dy over dA. Now we are looking at a as our variable. We consider a as our variable. Somehow, a is to the exponent 1 there, a is to the exponent 1 there. If I apply differentiation rules, I have to take the 1, multiply it in front, and subtract the 1 as well. So this is going to be 1a, 1 minus 1, x squared, plus a, because the 1 gain in front. I'm going to say 1 times 1, 1 minus 1, like that, I guess. But I just want to show that this is going to be 1 times a is a. 1 minus 1 is 0, x squared plus 1 times a is a to the exponent 0. Any number to the exponent 0 we all know is 1. Therefore, to simplify this further, we'll have x squared plus 1. Therefore, dy over dA for this is x squared plus 1. So that's it, guys. That's how you solve question 7 so far. That was not so hard, was it? I guess not. But anyway, please join us for more videos like this. Follow us on Facebook, follow us on TikTok, follow us on, or subscribe rather, on our YouTube channel. Our learning channel is also accessible through Spotify. So when you go to Spotify, when you go to your Spotify app, you search for the learning channel. And you may as well want to follow us on Spotify. Actually, please follow us in all the apps. I'm Mr. My Money. This is Simplified RSA, the guys who makes it looks easy. Until next time.